This is an application problem where we're able to apply our knowledge of the trig ratios to calculate in a real life scenario. So our question says, a wire is stretched from a point X on the top of a building, here, which is 14.5 meters high, to a point Y on the top of a tall building, 22.4 meters high. The angle of elevation from X to Y is 12 degrees and 15 minutes. What is the horizontal distance between the two buildings? So we're trying to find this horizontal distance here. To use our trigonometric functions, we need to know an angle and a side. If we're trying to find a side, we need another side and an angle. If we've got an angle, we definitely don't know how long our zip wire is. We don't know anything about that direction. So it must be this side that we can find the length of. We know how tall this building is, 22.4 meters, and we know how tall this building is, 14.5 meters. So finding the difference between the heights of the buildings will give us this side length here. So that side length will be 22.4 meters minus 14.5 meters. So the height of our tallest building, the difference between the height of the tallest building and the height of the smaller building, that would be 7.9 meters. So we have an angle, we have a side, and we're trying to find the other side. So we start by labeling the sides of our triangle. If this is our internal angle, then this side will be the opposite side, and this will be the adjacent side. When we have opposite and adjacent, we use the tangent function. So tan of our angle equals the opposite over the adjacent. We can substitute our values in. We know the angle is 12 degrees and 15 minutes. The opposite side is 7.9 meters. And the adjacent side is just this letter D, the distance. We don't know what that is yet. That's what we're trying to find. So if we want to find the distance, we need to rearrange our formula. We can do that by multiplying both sides by D, getting this distance off the bottom of the fraction, which gives us D times tan 12 degrees and 15 minutes equal to 7.9. And to isolate our D, we need to divide both sides by tan of 12 degrees 15 minutes. That happens to both sides of our equation, just to keep them balanced. Tangent of 12 degrees, not tangent of tangent, 12 degrees 15 minutes. So on the left-hand side, we're left with our D. This multiplied by and divided by tangent will cancel each other. And that tells us that the distance between the two buildings is 7.9 over tangent of 12 degrees and 15 minutes. So you can see here that effectively our D distance down the bottom and our tangent up the top on this side have switched places. D ended up over here and the tangent ended up over here. So we calculate that distance by entering into our calculator 7.9 over the tangent of 12 degrees and 15 minutes. Remembering that the calculator can interpret 12 degrees and 15 minutes using our degrees, minutes, seconds button. And that tells us that the distance between the two buildings is 36.385 meters. If we want to round that off to two decimal places, our distance will be 36.3. The 5 makes the 8 round up to a 9 meters. Because this is a worded or application problem, we need to give a final solution to interpret this number that we've calculated. So therefore, the distance between the two buildings is 36.39 meters. And that's the answer to our question.